Thank you. So, types of loads that we have to take is your dead load, okay, live load, wind load, disabled load, earthquake load, and also all these loads are carrying what? Dead load, live load are going downward. Okay, the impact is due to the gravity. Wind load, how it is coming? It is coming horizontally. Wind load and earthquake load, it is coming horizontally, and the impact will be, it will be able to topple the structure, and because of that there will be impact in one side, and there will be also uplift pressure due to the presence of water in the soil. So for that, especially for expensive type of soil, you will find this type of uplift pressure where the load is, where the structure will be pushed upwards, opposite to all this type of load. So what will happen if there is settlement of the foundation? Okay, you will find there will be deformation of the foundation soil. It is called settlement. The downgrading of the soil settlement is called settlement. And also, what there should be some permissible limits that is assigned for different types of, based on the type of soil and the type of foundation that you are using. There is permissible settlement marks are there which are used. Okay. Uniform settlement is what? When the whole structure is uniformly settling. Means every foundation, every part, there will be minimum tolerance 2 or 3 mm, and based on this, the structure is wholly settled. That is called uniform settlement. And if there is undue settlement, where the settlement is not uniform, some columns may settle more, some columns may settle less. These are called differential settlement, and these are more problematic. As you can see, this will hamper the structure of the main frame of the structure, and because of that there may be points in the beam column joints. There may act as a weak point, and this will be responsible for the collapse of the structure. So our settlement of the there is another primary requirement of the foundation should be such that it will be able to take the load and transfer the soil uniformly without having differential settlement. Okay, this is one of the means with not only just to carry the load on the structure, it should also take the load uniformly and transfer to the ground without having any differential settlement. That is also very much important. Okay, so that is why not only isolated footing, different types of mat footing or raft footing are used, so that our structure will be able to stay in the ground in a stable horizontal position. Okay, so different types of soil characteristics that you have already know from your soil kinetic diagram. Okay. The load of the building that is coming, that are transferred to the foundation into the underground. Based on the different size of the particles, you can classify the soil. In the boulder, boulder and cobble. What is the size? Around 80 mm. Gravel, porcelain size particle, then sand. 4 to 0.75 mm. Okay, there is 4.75 or around 5 to 0.005 is the range. Silt 0.005 to 0.02 mm. Clay less than 0.02 mm. And pits, organic ants are not at all suitable for the foundation. And depending your large gravel type particle, they are able to take the load more uniformly, and they are stable. But when it comes to sand or silty particle, there will be more uneven settlement. Okay, so you can say that it is very difficult to prepare any construction in the zone where there is sand. Okay, so like in Dubai. Okay, so even if there is having a very big bearing capacity of the ground because of the sandy soil, still they have prepared multi-rise building. Okay, that is called engineering. So there will be challenges, but to overcome this, there will be some solution that is to be taken. Okay, this is the nature of the sandy soil. Cohesive in nature, it is motionless, and the resistance offered is due to the internal friction of the particles. Okay, in clay, this is the cohesive soil. So this offers resistance between the particles. So in the sandy soil, because of there is the totally depends on the internal friction, which is actually less. So that is how it will be not be able to bear much of the load. And for the same, in the same way, there will be internal cohesion between the clay particle. It will be bounded, but some of the clay particles they are very uh, they may exclude the water when they are compressed. Okay, so what is that called? When the water is expelled and when the soil is compressed, what is that phenomenon called? Compaction. So due to compaction, and what is consolidation? If that is compaction, what is consolidation? Compaction and consolidation में basic difference क्या है? Air water बरोबर है और consolidation है water बरोबर है. ठीक है भूल बोल. So consolidation, so with the actually what compaction is event being instantly, but compaction it is instantaneously. It is taking time. It is long. It is taking more time, and with the passage of time, the water void is getting up. Okay. So there will be the intermolecular attraction. There will be cohesion in the clay particles. So this is how they gain the strength for in the bearing of the sand. They take part. So these are the basic important steps that are required for your foundation construction. First, operation is your excavation. You know, you have to excavate the soil because the foundation is to be prepared underground. And if the it may sometimes happen that the depth of the excavation may vary with the level of the operation where our level has been assigned by the surveyor. Okay. So based on that, it may vary. And what are the different excavating equipments that we can use? We can use backhoe or dozers. Okay, dozers for digging up the material, and backhoe we can use for excavation part. After the excavation work is done, okay, so what will happen due to the arc pressure, the side of the excavated the matters, they may not be able to stay there. Okay, they will have due to the active pressure, they will try to fall. Okay, so we can avoid the excavation that is to be done. The side walls need to be protected so that they does not fall by making some measurements by using benching or sheeting or bracing. Okay, we will see all these measurements. Once the sides are protected so that due to the passage of pressure it will not fall, we have to make sure. Sometimes what will happen, if the water level is at higher level at shallow depths, then there will be watering. The water will percolate inside your foundation pit. That pit need to be dewatered. The water need to be removed. Unless and until we do not remove the water, we won't be able to do our construction work. Okay. So next stage is your dewatering. It may not be always the case in some of the cases, but most of the cases you may have to perform the dewatering because of the shallow depth of the water level. Okay, understood? So also why? Adoti? Cannot dewatering बोलता है? ठीक है? Dewatering क्या बोलता है? मुस्तबल है? मुस्तबल है सुनिश्चित ना? Cannot dewatering बोलता है? These are some of the construction equipment that are used. Okay, you can use for excavation work, dozer or backhoe. Okay, the JCB below, it is actually what your backhoe. Okay. This is dozer, this is backhoe. Then to take out the material, we need bucket loader, okay, or steppers, or hard strata. We will use power shovel. Okay, in the next module we will discuss details on this. All this power shovel, then tractor mounted ripper. The pneumatic hammers, this we can use for hard strata, for soft strata, and for drop balls also, hand splitter also we can use for more harder strata, and for soft strata we can use simple backhoe. Okay. Even blasting need to be done for your harder strata, like for your excavation work, for your underground tunneling work, okay, or where the metro will pass. What we use, which equipment we use for underground preparation of underground tunnel? What is the common machine? What is the common machine that is used? आगे क्लास से हम लोग डिस्कस करेंगे. आगे सेमेस्टर. What tunneling work? What is that called? Round. It is round shape. And there is a roller mounted the hard starter and it will proceed. TPM. TPM. Yes. Okay, next is your protection. It is called protection from caving. Means when the excavation work is done, due to the earth pressure, the side walls will try to fall. Okay, and to protect it, we may use various methods. One of the common method is benching, where we will use steps. We will cut the, instead of cutting it vertically, okay, making a vertical wall, we can make steps so that the earth pressure will be raised. Okay, when there is plenty of space available in the adjacent area, we can use this method benching. There will be no extra cost required for use of any sheets or dressings. Okay, slopes are provided less than the angle of depots. We have to take out the angle of depots and slopes need to be provided. Instead of being benches, we can also provide slopes, and we have to see the angle of depots, and benches can be provided between. And it is very less expensive because there is no extra equipment that is required, and it is most commonly used. But what is the case if there is no space available? Okay, in a crowded city, there will be more space available in the adjacent area. There will be construction all over on the adjacent area. So for that, we can use different method, that is called sheeting. Okay, we will provide sheets, okay, patterns or sheets. They are clamped using these shoulder beams and legs. So with this, we can provide the sheeting, of which we can do the caving work, anti-caving. Protection from the caving. Next is your protection from the caving by using sheets. Okay, sheet pile. You must study in your semesters about sheet pile. This is your top view. Okay, this is the top view. And from the top, the cross section has been cut. Okay, this is the top view. So sheets are provided in inside the horizontal logs. Vertical logs are done into the ground. And by this way, by this action, we can provide some resistance. Also, there are some sheets like these blocks are there. Interlocking, they are attached, and by this way, we can create continuous barrier for the material to get stay. We can also use your cross-shaped sections which are attached. They are put and then again they are locked by using locks. So by this way, sheeting can be used for protection from the caving. We can use dressings also. Okay, sheets are inserted into the ground. Then this is the cross section side view. Okay. So this is the soil, and we can use different blocks. These are your dressings. Okay, these are called phosphate dressings. So due to this dressings, it will resist the fall of the caving of the ground. Okay, we can also use racks. There will be slopes and will be attached. There will be tie racks. Okay, so to keep some space here, there will be ties which will be inserted into the ground, and by this way it will resist the fall of the ground. Okay, understood? This is how the diagram is installed. You will first have a sheet inserted, then you will pass a rotated drill hole, then you will insert a grout, and you will do the pre-tensioning work. Okay, we will insert tender. Here it will be first we will drill the hole, we will insert the grout will be there, we will insert the tendons, and once the tendon has inserted, after a few hours it will get settled. Okay, after 24 hours it will get settled. Then from here we will do the tensioning work, and by this way, if you do pre-tensioning, it will get attached. Next is your dewatering. Dewatering is required where the water table is much higher level. Okay, so to lower to take out the water, you have to do the dewatering. The dewatering can be simply be done by using the pump, simple pump, okay, slump pump. So to make the place more dry so that the worker can work. Okay, how it may happen or why the water table is above the working platform. To keep it out, use the water out will require. Let the water in and then liquid using pump system, and we can have the calculation of this. by keeping a platform where the work can be done, or otherwise we can remove the water. We can also use watertight barriers. Okay, so as you can see, if we have a, suppose there is a pumping system, okay, and this is the water level. We have done our sheet work we have provided, sheet pipe we have provided for protection against caving, and we have also provided some watertight barriers. Okay, all parts are sealed so that, see, this is the seepage. So this graph is showing that the water is not able to percolate inside the sheet. So this is how the space has been kept dry by just diverting the water. There will be no seepage from this barrier, and the place where the construction will be done will remain dry. Types of foundation, commonly there are two types of foundation: shallow foundation and deep foundation. Shallow foundation, the different types based on the type of the soil, type of the what is the carrying capacity of the soil. Okay, based on the condition of the construction, the requirement of the construction, what is the weight, dead weight, and life load that is coming to the building. Based on all these conditions, we will choose our type of soil. Okay, so the purpose of all the foundation is to transfer the load into the deeper strata. Okay, and if the strata, hard strata is above the near above the ground, then by simply using shallow foundation you may apply in the foundation. And otherwise, for when the hard strata is much higher depth, then you may have to go for the deep foundation. Shallow foundation, it is suitable for soil bearing capacity, having sufficient soil bearing capacity, undisturbed soil or engineered field soil. Okay, this compacted soil is required. Basic preparation, we can use column footing, isolated footing, very common, right? Okay, and also we can use step footing or step footing. And also beside this, we have wall footing or strip footing, where a wall or strip of footing is done. So these are the basic types of configuration of the required for your shallow footing. Okay. Other type is your column footing combined with tight footing. Then combined footing, and mostly that is commonly used for your large scale construction, that is your raft or man footing. Okay, raft or man footing, in this what will happen, there will be combination of all the footings, they will be attached together. Okay, in your isolated footing, there will be only single column that is there, where at the bottom there will be footing. Okay, in wall footing there will be the single span will be connected together, but in the raft footing, all throughout the structure, the bottom will be connected together. Okay, there will be a slab type structure where they will be connected with every foundation. So this is how it is more stable. Raft foundation is able to take more load, and it is also utilized less space. If there is some adjacent space not available, then you may use for this raft or man footing. This is an example of your combined footing. Okay, if there is no wall there, then you call as combined footing. This is your isolated footing, and when they are connected, it is called your combined footing or strip footing. So this isolated footing can only be available where the cross-section area is sufficient with the depth to form a spread footing. Okay, if there is a single column, and if the bearing capacity of the soil is not sufficient, then you may have to go for your combined footing or strip footing, where this type of footing will be able to resist your undue settlement. Okay, so due to the uneven settlement, the isolated footing may not be applicable, and if the soil strata all throughout is completely desirable for construction, then we will go for the asphalt footing. Otherwise, we have to. So the combined footing is more desirable if the soil strata compaction is not even throughout. Okay. So if it happens that this portion is not compacted or the soil, but in this area, this part is different compared to this strata, the hard strata is at much better depth. Then you may use the combined strip where it will raise your uneven settlement. This is the mat foundation. See in the mat foundation, this may be used where for large scale construction where there is a high rise building and there is a high chance of uneven settlement. We may provide a mat which will be able to take the load uniformly, and even if there is a settlement, the settlement is uniform throughout. This is how the mat foundation is taking care of the uneven settlement. Next is your re-footing. So there are different types of footing that you have seen. Okay, pile footing or cassette footing or wall footing. So the pile footing may be of two types. One is your friction pile, where the bearing of the load is taken care due to the friction of the adjacent soil strata. Okay, from the friction, the structure is able to, the pile is able to carry the load of the structure. In end bearing pile, the pile is drilled to the strata where there is hard at the bottom, to a much depth, and the load is taken care mostly by the end bearing. From the hard strata, the load is taken care. Okay, or if you say the combination of the friction and the load strata, the load is taken care. In cassette footing, it is more of hollow, more of more spread, and here it may go to beyond near about your hard strata where the load is taken care by the end bearing. And in socket castle, even if the drill has reached the hard strata, it may go much beyond, and due to the end bearing where there is more spread over here, so the castle load is able to take more load, and only few numbers of castle your piles, they may be desirable to take the maximum of the load, and in friction pile or end piles you may be required more number of piles to take care of a particular area. So based on the different load transfer, as I have told, friction pile and end bearing pile, based on construction method, we can use piles like a concrete pile, precast driven piles. Okay, recently in the site visit, which type of pile you have seen? Precast type piles or board casting situ piles? Where board. So this type of board casting situ piles you might have seen in your site visit. Okay, so you can see the equipment of the diameter and the depth is done on the reinforced concrete is placed on the top of pipe.
Board reinforcement cage right casting.
Then there is the casting. And in case of precast drives, already the casting will be done, the pipe will be ready, then they are inserted by the MRE. By the number of blows, it will be put inside. Then, other things we have driven casting screw piles, where the casting drive is initially in the form of reinforcement that is put, then casting then concrete is placed, after that the soil inside is casted. Okay. So, combination of this is your drive casting set. Then the pile material may be different, it may be steel, it may be concrete, it may be timber, or it may be composite. Okay. So composite means the combination of your steel and your concrete. Okay. Concrete is a casting situ or precast, steel is your H piles or steel piles can be used. These are some of the examples of your H piles. Okay, that's all for today. The next class we will discuss about the building planning.